Welcome back, everyone. This is part 2 or 3 maybe for deep learning using transfer learning. We are going to learn transfer learning and apply it to a problem of balance detection. We are following a paper, this specific paper, and we are trying to do it as the paper suggested. So in the first video, I have created the model, make the data set, and in this video I am hoping that we will be able to train the model and see dive into k-fold cross validation stuff. Okay, so before I continue, I'm just gonna show you what does the k-fold cross validation means actually. I found an interesting picture for k-fold cross validation is that sometimes you want to train your entire model, you want to train your model on the entire data set, but you also have to keep some for testing the model, for testing the model's accuracy. Yes, so for that you often, I often keep 90% for training and 10% for testing. So sometimes you want to use the 10% for the testing for training as well. So for that, we often use a k-fold cross validation. So what it does is that it takes all of the performance from the model. Let me start from the beginning. What it does, so the k-fold means that the k is the number of times you want to fold or divide the data set. Suppose you have 1,000 images and you want to use a k number of 5. So you will divide fold the data set in 5 different divisions, so 200, 200, 200. So in here, in the first part of the k-fold cross validation is that you will use the first part, the first 200 images as your testing data, and the rest, the 4 folds for 800 images for the training. So that will give you a performance of the model. The next, the number 2 model would be trained on these, the blue ones will be the testing data. The second, the from 201 to 400 will be your testing data, and the rest, the first fold and the last 3 folds, would be the training data. That will be your performance number 2 or model number 2. So you will have you will iterate through it, and all of the performance will be mean, will be taken an average, and that will be your entire performance of the model. So how this helps is you are exactly training the model on the entire data set, and you're taking the average of all of the performances. So it's a very useful feature for this. So in this paper, they have used the k-fold cross validation. So that is what we are going to do. Here you can see that these are the they have folded in tens, folded the data set in 10 different parts, and that is what we're going to do here. So for the k-fold cross validation, there is a thing called the k-fold, and we need to import it from the, I think it's the scikit-learn library. Let me just check. Yes, there is so there's a library scikit-learn. So there is a function or dependency that you can use to figure out the k-folds and stuff. So I'm going to import it. So from sklearn.model selection, import k-fold. Yeah, okay. So after importing k-fold, we are going to use this k-fold to do a k-fold of 10. So we are going to specify the parameter here. So giving it a 10 because it's 10 folds, dividing the entire data set in 10. So and now what we have to do, figure out the x's and the y's of the model that we're trying to fit here. So I'm going to specify the x to be the np.array of I of 0th, because 0th element is the image, and the 1th element is the label of the data. So for I in data was as you remember, data was our entire model, entire data set. So this will be under here like this. Okay, now reshaping. It is a reshape, but it's better to do it like this because we are throwing in batches of data. Image size, comma 3, and the y's would be np dot array of I of 0 for I in data. No need to reshape it because it's just the label. Now to normalize the values between 0 and 1, gonna specify the type as float 32 and divided the entirety by 255 to normalize the values. Gonna specify the full number equals 0 here. I don't think we're gonna need this, but if we want to save all the models here, we should, you know, save this. So for train test, test in kf.split, and you can split the data in 10 folds. Fold plus equals 1, increasing number of folds to count how many fold is going. So I'm just gonna print it out. So training on fold 1, training on fold plus fold str, specify it like this. Yeah. Okay, so the x train would be the x train, all of those. The y train would be the y of the train. The x test would be the x of the test, and the y test would be the y of the test. Okay. We're gonna specify the Tensorboard so that we can see the increasing the graphs and stuff. So we need to name the model beforehand. So naming each of the model like this. Specifying as a movie model because we are gonna we are training that model on the Movies Dataset. So calling it movie model. And we're going to specify the full number of the model because we're going to we are going to show the Tensorboard graph of each of the model. So that is what we're going to do. Fold. Okay, so Tensorboard. We did not import Tensorboard. Yes, I remember now. Tensorboard be capitalized. Let me just import Tensorboard before I forget. Callbacks. Sorry, that's my messing. Okay. TensorFlow.keras.callback. Import Tensorboard. Okay. Tensorboard, kind of important name for Tensorboard. Why? Because of these catalytes. Right. Yep. Now it's good. So let's specify the Tensorboard. Here, so specifying the logging log directory as logs slash this curly braces, and in the curly braces I'm going to format, if I can write format the model name. Now for the fitting or the training part, so model.fit would be the X train, the Y train, not Y test, Y train, the validation data would be x test comma y test. Y test. Verbose would be 1. Epochs would be the number of epochs. Oh, capitalized. Batch size would be batch size. Batch size. And callbacks would be the thing that we have created. Tensorboard. Yes. Okay, ending the model.fit. Gonna save the model later, like yes, I'm going to save the model. Here I'm going to specify as movie model sigma softmax. This was a softmax problem. The softmax main.h5, and what are we going to save is the model, and if it's already existing, so I'm just gonna override equals true, and obviously we're gonna include the parameters, optimizers and stuff. Optimizer equals true. Yep. Okay. Oh, one thing I forgot to do when we created the model is that we did not specify the optimizer. So that is what we're going to do now. So model.compile. No, I'm going to use it as separate here. So model.compile, and that the loss of categorical cross entropy optimizer as Adam. Optimizer std stochastic gradient descent, not Adam. Learning rate of learning rate. Momentum of momentum. Okay, now the metrics would be the accuracy. What else? Nothing. Okay, optimizer is not defined. Optimizer is not defined. So optimizers is not defined. Yes, of course. Close. I didn't import optimizer. Yes. So from TensorFlow.keras import optimizer. All will not be capital. Optimizers. Yes, imported. I think it's gonna work now. Yeah, so we have compiled. Now for the training part. Did we miss anything? I'm just gonna cross check here. I don't think we have. We don't need to evaluate. Okay, yeah, that's about it. I think we are good to go for training. How many minutes has it been? It's 13 minutes only. It was a quite short video. Just I'm gonna start the training. Hopefully it works without any error, but we are gonna solve the errors together. Okay. Let's see. Okay. Yeah. Hopefully it is gonna work now. Now, so yeah, my model has started training. So as you can see, it's very low in the end. 50% started from 50%. All models should start with 50%, and like, you know, step by step increases its accuracy. As you can see, before the first epoch has been done, it is like, you know, 55, 56%. So yeah, it's gonna continue on 5 epochs, and it's gonna continue on 5 epochs on each of the folds. So there are 10 folds, so there are gonna be 50 times like the model will be fit on. So yeah, that's about it for this video. So I've shown you how to, like, you know, do the transfer learning in this video, how to implement a paper. we did not exactly, wasted time, spend time on reading the entirety of the paper, but I have read the paper before to save the time and marked down some of the important things that I have found useful. So you can read this paper. I'm going to give a link to this paper in the description down below. The link to this GitHub repository will also be in the link, like in the description below. And later we are going to, I have plans for making like basic Python videos, or basic programming concept. Like, there are a lot of Python videos, tutorials out there. So what I'm going to target is to make the programming concepts very clear, the fundamental concepts clear to you. You can watch other videos, like other YouTubers who have very good quality content of learning Python or other deep learning frameworks. So I'm just gonna specify in the the nitty-gritties and most fundamental stuff in this channel. So I hope you like it. If there's any questions, comments, and concerns, you can leave it in the description down below. Oh, sorry, leave it in the comments down below. And I will see you next time in the next video. Yeah, thank you. Have a nice day.